Assalamu alaikum students. Hope you all are fine and safe. Since it's our first online lecture, I'll try my level best to make today's lecture clear to all of you. But before starting, I request you to please watch this video attentively so that it will be convenient for you to attempt your worksheets. So let's begin. Students, we'll begin our classes from the second week as mentioned in your SOS. By the end of this topic, you will be able to know what this chapter is all about. That is, introduction of chapter. Then, what is thermal expansion and contraction? Thermal expansion and contraction of solids. Thermal expansion and contraction of liquids. Thermal expansion and contraction of gases. And in the end, the conclusion of this topic. I would like to introduce this chapter by some diagrams. What is the reason behind leaving the spaces in between the railway tracks? Or what is the reason behind the movement of mercury in a thermometer? Why is it so that when you place a bottle with a balloon on it in the hot or cold water, the balloon blows or shrinks respectively? Why placing a D-shaped tennis ball in hot water helps it to regain its shape? This is all happens due to the thermal effect or effect of heat on these substances that are mainly solid, liquid, or gases. So let's discuss what is thermal expansion and contraction. Thermal expansion is the tendency of a matter to change its shape, area, and volume in response to a change in temperature. Thermal expansion is the shrinking of substances as they cool. Changes in temperature changes the physical properties of substances. So the reason materials expand when heated is because the heat gives the molecules energy, and as a result they begin to move, leaving them further apart, and hence the material expands. Whereas in cooling, the cooling has the opposite effect. The particles move closer together, causing the molecules to contract. One of the expansion is of water, which expands on cooling, which is also known as the anomalous or peculiar behavior of water. Most of the substances are denser in their solid or frozen state. But in case of water, when it freezes into ice, it becomes less dense because of hydrogen bonding. The water that is heavy displaces the ice that is light in weight. So the ice float on the top of the water. Students, remember that ice is 9% less denser than liquid water. So when the substances expands or contracts, the particles stay the same size. Only the spaces between the particles changes. The particles in the solids vibrate when it is heated, thus takes up more room or expansion. Similar is the case with the liquids and gases when they are heated. As you can see in this diagram, the molecules of solid materials are at their mean position, or you can say stationary at room temperature. But as soon as you provide high temperature to solid material, the molecules that were tightly packed before now vibrate at their mean position, showing to and fro motion, and hence will take more space and increase the volume, shape, and area of this solid material. Whereas the molecules of liquids are already far from one another, but upon heating, the molecules start moving from their original position and hence increases the volume. The gas molecules are also far apart from one another, and when heat is provided, the molecules move in all possible directions and thus expand. Let's discuss the thermal expansion and contraction of solids. When solids are heated, their particles vibrate more rapidly, pushing each other apart slightly, causing the solid to expand. The amount of increase in volume depends on the type of solid, example, a bimetallic strip. We'll discuss this in our next slide. So different solids expand or contract differently upon heating or cooling. Similarly, decreases in temperature causes solids to contract by varying degrees. For example, the power lines need to hang from the pole at the correct tension. If the tension is too tight, the power lines will contract and break in cold weather. If the tension is too loose, they will expand and hang too close to the ground in hot weather. So, due to the rise in temperature, a substance molecules jiggle faster and move further apart. This is basically the reason why the spaces are left in between the railway tracks. If not left, the railway tracks will bend and causes accidents to happen. This is another example of this phenomena. Warming metal lids on glass jars under hot water loosens the lid by more expansion expansion of the lid than the jar. These are the three experiments by which you can see the phenomena of thermal expansion and contraction of solids when heated or cooled. The first experiment is about the metal bar and metal gauge experiment. At room temperature, this metal bar will completely fix into this gauge. But when you heat this metal bar, the bar will expand due to the movement of its molecules, and it is unable for it to fix in this metal gauge. Whereas when you remove the heat, after some time, this bar will be able to fix in this gauge again. The second experiment is of metal ball and the metal ring. At room temperature, the ball can easily passes through this ring. But when you heat this ball, it will be unable for this ball to move from this ring because of the increase in the volume, shape, and area of the ball. The third experiment is of bimetallic strip. When you heat it, one of the metal strip, for example brass in this case, will absorb more heat and will cause the whole strip to bend upward. Example brass in this case. And upon cooling, the brass will cool more and bend the strip downwards. This is an example why I've said earlier that different objects, either solid, liquid, or gas, show different behavior upon heating or cooling. Now let's talk about the thermal expansion and contraction of liquids. When liquids are heated, their particles move around more, pushing each other apart slightly, causing the liquid to expand. Liquid expands more than solids when heated. This is because the particles in the liquids are not held in a fixed arrangement, so this increased freedom of movement results in greater expansion, as we have discussed earlier. For example, a thermometer. At room temperature, the mercury of thermometer is inside this bulb. But when you heat it or give a high temperature, the mercury starts to move upwards. For example, if you place the thermometer in your mouth the mercury will expand due to the high temperature, giving a reading either of a normal body temperature or gives indication of a fever. This is the apparatus used to show the phenomena of thermal expansion and contraction in liquid. A round bottom flask with a liquid inside it is held with this stand. When you place a spirit lamp and heat the flask, the water level first decreases due to the expansion of flask because the heat reaches the solid flask first. Then it moves to the liquid and causes the level of water to increase. And on removing the spirit lamp after some time, you will notice that the level of liquid will fall down due to the contraction of its molecules. This is an experiment that shows the phenomena that different liquids expands or contracts differently when heated or cooled. In this, the ether expands more, whereas the water expands least among all of these liquids. And this is why mercury is used in thermometer instead of water. Now let's discuss the expansion and contraction of gases. As you can see, when the gases are cool or are at room temperature, the molecules are far. But when you heat the gases, the molecules will move apart and hence expands. So, expansion of gases is when the gas is heated, the molecules gain more energy and move faster and further apart. This causes the volume to increase. And in contraction of gases, at a lower temperature, the molecules have moved slower and have less energy. They are closer together, causing the volume to decrease. This is an apparatus showing the phenomena of thermal expansion and contraction of gases. A round bottom flask containing an air or a gas in it is placed on a Bunsen burner. Upon heating this flask, the molecule starts expanding and will move in all possible directions, and hence passes through this capillary tube and reaches the water in the beaker and forms bubble in the water. Whereas when you remove this Bunsen burner, the gas starts to contract and will move back into the flask. You will be astonished to see that with the backward movement of this gas or air, the water in this beaker will move upward and will fill half of the flask. This is because the molecules of gases will contract so much that they fill only half of the flask. This is the link of this experiment. You will surely enjoy when you watch it. So students, this is all about our today's topic. Let's talk about the key points of today's lecture. Number 1. As the temperature of a solid, liquid, or gases increases, the average distance between the atoms molecules of the substance typically increases, causing the substances to expand. As the temperature of a solid, liquid, or gases decreases, the average distance between the atoms and molecules typically decreases, causing the substances to contract. Number 3. Heat expansion or contraction can happen to solid, liquids, and gases that are states of matter. Number 4. Expansion and contraction due to changes in temperature is not permanent. Example, objects that expand when heated can also contract when cooled. Next, the number of atoms and the mass of atoms does not change with the changes in temperature. Only the spacing between particles changes. And different types of solids, liquids, or gases expand and contract differently, as we have discussed. For example, solid metals that are made of pure elements like copper and aluminium are better at absorbing heat than alloy metal like brass, gold. Gold is probably the best heat conductor, but it is so expensive that we don't use it much. Brass is an alloy of copper and zinc, as we have discussed in the example of bimetallic strip. An alloy is a metal made from combining two or more metallic elements. You must have discussed this point in your chemistry classes. So, students, I hope that your concepts up till now are clear mostly, and you are now able to do your worksheets as well. Looking forward for your 99% response. In our next class, we'll discuss the effects and application of thermal expansion and contraction. Till then, thank you and Allah Hafiz.